I want to go over the p-value approach. And what you have in front of you is we have a null hypothesis that states, oh, the mean is 35. We have the alternative hypothesis, it's not 35. And our significant level, or alpha, is 0.05. Now keep in mind, when we're utilizing the p-value approach, our so-called critical statement would be reject the null hypothesis if the p-value is less than 0.05. Let me repeat that. Reject the null hypothesis if the p-value is less than 0.05. Or fail to reject the null hypothesis if p is greater than 35. So in this particular situation, what you have in front of you, we have that so-called test statistic, z, is 2.47. 2.47. So what we have done here is that, in other words, we have gone, if you look at the normal distribution, we have gone 2.47 from our hypothesized mean of 35, and you can see that we have a two-tailed test, so we have 0.025 on the right tail and 0.025 on the left tail. If it was just a one-tailed test, we would just have a value here. Alpha would be 0.05 or 0.05 over here. One-tailed tests, you don't have to be concerned about what values are in either tail, just with a two-tailed test. And I think that'll become a little bit clearer as I go on. Okay, so from our standpoint, this critical value for z is 2.47. As I pointed out, that's a negative, right? So we would be going a negative to the left from our mean of 35, 2.47. So if we would look at our table, these are the tables that I have provided for you, is that if we go to those tables here, if we look for 2.47, we would come up with 0.4932. 0.4932. Now 0.4932, since this particular table is looking at 50%, so if we're to the left or we're to the right, one is simply the mirror image of the other. So negative 2.47, let me go back to the table, negative 2.47 constitutes an area of 0.4932. So what we are saying, the area from the mean of 32, if we go a negative 2.47, happens to be 49.32. So what's the area outside? Or the area outside would be 0.0068. And that's what we're showing here. P-value is 0.0068. Okay, that's the difference between 0.4932 from 0.5. So since it's a two-tailed test, we would simply multiply it by 2 and end up with a p-value of 1.36. Therefore, as I pointed out, reject the null hypothesis if our p-value, 1.36, is less than 5%, which it is. So we would reject the null hypothesis and conclude that this sample that has a sample mean of 33.6 did not come from a mean, did not come from a population that has a mean of 35. Let me repeat that one more time, right? We have a p-value of 1.36 is less than our level of significance of 5%. We would reject the null hypothesis and conclude that this mean here of 33.6, right there, 33.6, did not come from a population that has a mean of 35. So this is just kind of a very quick way of introducing you to the p-value. There are some other videos up there that will assist you in further focusing in on this underlying concept for the p-value. And I will say the p-value is an important concept due to the fact when we get into chapter 4, when we deal with regression analysis, that'll be the forefront. Because really when we do it in Excel, Excel is going to give the p-value to us. So we don't have to calculate the z-value. We don't have to relate that to a standard normal distribution or to a t-distribution. We just look at what the p-value happens to be, and that's one of the reasons why I focus on the p-value.